All right, so question number 1 on problem set 18 first asks you for all the names of all the enzymes that are involved either in glycogen breakdown or glycogen synthesis. So there are 3 enzymes involved in either process. So in glycogen breakdown, 3 enzymes are glycogen phosphorylase, glycogen debranching enzyme, and phosphoglucomutase. All right, in glycogen synthesis, there are again 3 enzymes. The first one is UDP glucose pyrophosphorylase. The second one is glycogen synthase, and the third one is branching enzyme. All right, or glycogen branching enzyme, if you want to call it that. All right, now the second part of the question asks you to draw the mechanism for the enzymatic steps that are involved in either making or breaking the alpha-1,4 linkages of glycogen. All right, so I'm starting off here with the mechanism of glycogen phosphorylase. So in glycogen phosphorylase, it includes a PLP cofactor, and this enzyme takes advantage of the phosphate group that is a component of that PLP cofactor. In addition, there is a second phosphate that is present in the enzyme active site that is going to end up being attached to the glucose that gets cleaved off. And then we have up in the top here our glycogen molecule. All right, so the way the mechanism proceeds is, first of all, a lone pair of electrons on the cyclic oxygen are going to push themselves down to form an oxygen-carbon double bond in the ring here. All right, this is going to necessitate now the loss of the bridging alpha-1,4 bond. All right, so in order for that oxygen to be lost, all right, it needs to be protonated. All right, so it's going to pick up an H plus from that extra phosphate group in the active site. All right, and those electrons are going to be pushed onto that oxygen. Well, having a tribasic phosphate in nature is just very, very hard to have happen because the pKa of that process is extremely high. Right, it's very hard to have phosphate with 3 negative charges on it. All right, so instead, to compensate for the loss of that one proton, all right, that phosphate has to pick up a proton from another phosphate, this time the one that's bound to the PLP cofactor. All right, so now it's an intermediate step. We have this cyclic oxygen here with 3 bonds to it and a positive charge on it. We have a phosphate again, and the phosphate that is bound to the PLP cofactor doesn't have any hydrogens on it. All right, so now we are going to do a nucleophilic attack because this positive charge is actually, there's resonance stabilization, because I could draw this structure here. Instead, I'm just going to draw the ring form here. Right. If I took the 2 electrons in the double bond, the carbon-oxygen double bond, and pushed them onto the oxygen, I could have this resonance form as well. So that positive charge is delocalized between the oxygen and carbon-1 of the sugar. All right, so the phosphate is going to attack carbon-1 there. In the form shown in the top, it'll push those electrons up onto the oxygen. If you're starting with this resonance form here, those electrons are already on the oxygen, so you can simply do the nucleophilic attack. It doesn't matter which way you choose. All right, now once you do that nucleophilic attack, this phosphorus is going to want to lose that proton to donate it back to the PLP cofactor. All right, and it goes ahead and does so. And then result now is we have our glycogen, our glucose 1-phosphate here, and on the right we have our glycogen with a new non-reducing end. Erase some of the stuff here, and then we'll go down here and we will look at the mechanism of glycogen synthase. Okay, so glycogen synthase utilizes UDP glucose as the glucose donating compound, and this is going to get added to one of the non-reducing ends of glycogen. All right, so in the first step of this mechanism, that UDP is a really, really good leaving group. All right, so it's going to spontaneously leave on its own, and this is basically going to be an SN1 type reaction. So the way that's going to happen, a lone pair of electrons on the oxygen are going to collapse down, and that's going to cause now the phosphate, the terminal phosphate of UDP to leave. All right, so now we have this positively charged oxygen intermediate, and just like last time above, we could alternatively draw that positive charge on carbon 1 here by pushing that double bond, those 2 electrons in the double bond up onto the oxygen as a lone pair if we wanted to. All right, so at this point now, carbon 1 is extremely electrophilic. All right, this allows now a base to deprotonate carbon, or the oxygen on carbon 4 of glycogen, one of these non-reducing ends. That oxygen can then come up and attack carbon 1, which has that positive charge on it, and those electrons get pushed up onto the oxygen, and our UDP has already been made. It can leave the active site. All right, well, at this point then, we have made our we have basically added 1 glucose unit onto glycogen. All right, so that's it for problem 1 on problem set 18.